Okay, I want you to take your notes packet and I want you to turn to the page that says volume of spheres. We've already worked quite a bit with volume of different shapes, but now we're looking at spheres. And I want you to look down. I want you to find volume of sphere. So here's volume, here is sphere, here is our formula. Now, this one's a little bit different than our prisms and cylinders or pyramids and cones, because notice we don't have a capital B. If we're talking about a sphere, what are some examples of a sphere? A sphere would be like a beach ball, a ping pong ball. I'm trying to think even, what's something that wouldn't be a type of ball that would be a sphere? Maybe a rock or a marble. Ooh, that would be good. A marble. Those are all examples of spheres, right? Okay. And if you can't read that very well, I'm going to write it a little bit better. 4/3 pi r cubed. Notice this is cubed now. Okay, so what does the V represent? Duh, we know that the V represents the volume of the sphere. What does the R represent? You already know that the R represents the radius. Does a sphere have a base? And the answer is no, it doesn't have a base. That's why we don't have the capital B in our formula. And what does the 3 represent in the formula? I want you to know that it is an exponent. And it represents that we're going to cube the radius. We're going to cube the radius. So volume equals 4/3 pi r cubed. Okay, I want us to look at a couple examples together, mainly so that you know how to use your calculator. So if you turn to that example page, the next page that we've already worked with, I want you to kind of look. I mean, hopefully you're seeing very easily which shapes are spheres. Number 5 is a sphere, 7 is a sphere, 11 is a sphere. Okay, so really it's just as simple as filling in our formula. So again, I'm just going to keep reminding you, and you can always look on your formula chart. Here is your formula. Okay, remember, I think it's really important to plug it in on your paper, because then you can always cross-reference with your paper and your calculator. So 4/3 pi, that's like how it is all the time. Our radius, halfway across, is 3 cubed. Okay, so let's look at see what this looks like with our calculator. I'm going to do a new document. Hold on just a second. Okay, so I got my calculator. One thing that I do recommend is sometimes we get messed up when we put in fractions. So really important to me, make that fraction first. I just do it simply control divide, but remember you can also use this toggle key, but get it so that it's fraction formatted. 4/3. Notice my cursor is in my denominator right now, so I'm going to right arrow so that I have the nice big cursor. I'm going to use my pi button, which is down here at the bottom. Right there, pi. Okay. And then I'm going to type in times 3. And then remember to do an exponent larger than 2. One way is to hit this little housetop key, roof key, to the 3rd power. Okay, there's other ways to do that, but I think that's the fastest and easiest way. And then we hit enter. The direction said to round to the nearest tenths place. The 0 is in the tenths place. The 9 tells it to round up. So it would be 113.1. The volume is 113.1 cubic feet. Remember, volume is cubed because we're talking about 3 dimensions. Okay, let's just do one more together. I think, you probably should be really familiar with this right now. Let's do number 7. Okay, I'm just again writing the formula. Okay, let's fill in our numbers. We've got 4/3 pi. My radius, still my radius because it's halfway across, 7.5 cubed. Okay, so now I'm going to take my calculator. I'm going to make a fraction again. I'm sorry, it keeps auto-focusing. Okay, I'm going to type in 4/3. I'm going to get my cursor out of the fraction. Pi down there at the bottom left times 7.5. Caret house roof key to the 3rd power. Now, really important, I know you may be like, I don't want to take these notes, I'm going to go through really fast, but really important, you've got to make sure that we're getting the right answers with our calculator. Because that's where we're going to probably make our errors. And so our volume here is 1,767.2 cubic meters. Okay?